All right, here we are to do some exercises. Uh, with exercises, I want to give some tips. With these videos, make sure you're doing the exercises yourself first, just like it was in class. At least take a few minutes to try it. If you're struggling with it, that's okay. Give it a few minutes, try some stuff. Any tricks you might have to try to get it done will help. And if you're able to finish, just use this video to check your answers. When you get stuck, watch just enough of the video to get unstuck, then pause the video and keep going on your own. Remember that learning math is kind of like learning how to play piano. If you just watch somebody else playing piano, you're not going to be able to do it yourself. And with math, um, it's not like you can just write down the stuff and that's as good as doing it. Really doing it means figuring stuff out, and you got to do that as much as possible. All right, so, anyways, with that in mind, let's see these answers. So, for exercise 1A, do the whatever's in the parentheses first here, which is 5 minus 7, which gives you the absolute value of negative 2. On the other side, you do 5 minus 7, doing those absolute values first. So this gives you 2 equals negative 2, which is not true. Over here, we have 5 minus 7, which is still negative 2. The absolute value of that gives you 2. And so on the other side, we've got 5 plus 7, which is 12, and 2 is not 12. Over here, 12 minus 10 inside the absolute value is 2. Absolute value of 2 is just 2. Over here, we've got the absolute value of negative 2, which is 2. So that one works. Over here, let's see, the absolute value of x equals negative 3. That is true. That has no solution. Because the absolute value of x is always positive, so it can't be negative 3 no matter what x is. All right, here is exercise 2. Let's translate the English here into an absolute value equation or inequality, and then shade the solution on a number line. All right, so the distance from x to 0 is exactly 7. Oh, I was going to translate it first before the number line. So the distance from x to 0 is just x. The absolute value of x is what I meant to say there. And we're saying that is exactly 7. All right, so in other words, the absolute value of x is 7. It came out kind of ugly. Let me fix that. There we go. And to shade this on a number line, here 0, we want to go a distance of 7 in either direction. All right, there's my ugly number line. All right, so that could be x, or that dot could be x. All right, we're saying t is exactly 1 unit away from negative 10. So to translate this into absolute value, I'm going to rephrase it in terms of distance, like so. The distance from t to negative 10 is 1, is what this is saying. So that, in absolute value terms, is going to look like the absolute value of t minus negative 10 is 1. And, of course, t minus negative 10, you might as well write that as t plus 10. So you can just write it like that. And then a number line. Here's negative 10. Here's negative 11. Here's negative 9. Those are the things that t can be, which are two things 1 unit away from negative 10. Zeros over here somewhere. Okay, so here x is more than 2 units away from negative 10. Let's see what that looks like. Or let's translate it first. So if x is more than 2 units away from negative 10, to rephrase this in terms of distance, the distance from x to negative 10 is more than 2. That's going to look like, writing it in terms of absolute value, the absolute value of x minus negative 10, which you could just write as x plus 10, of course, is more than 2. Looks like that. So what does this look like? Right, so here's negative 10, 0 out here somewhere. 2 units from negative 10 would be at negative 8 or at negative 12. So we could actually not be equal to 8, but because we're saying more than, it might be like negative 7.9 or negative 7 or anything like that. Over here, got 12, negative 13, negative 12.1, anything like that, but not actually equal to negative 12. All right, for D, we got the absolute value of y is less than 4. So the absolute value of y by itself is just the distance from y to 0. That is what we're saying is less than 4. So if you're going to draw this on a number line, we're saying that y is closer to 0 than 4 units away from 0. So on the number line, we got 0, 1, 2, 3, 4. And go 4 units the other way. Don't want to include those, so I'll use that. And all of this stuff in here. Should make that work. All right. This one, I'm going to write this as, let's see. This doesn't say w minus something, but if we want to use this rule where w minus something in absolute value is a statement about distance, we've got to write it as w minus something. But what's going to go here? Well, I want it to be the same as w plus 20. So what you can do is w minus negative 20. That is the same thing as w plus 20, and this time this is saying the distance from w to negative 20 is less than 0.5, and on a number line, let's say this is 21 here, and 19, we're closer than half of a unit. So between 19.5 and 20.5, like so. All right, going on to exercise 3. Let's solve each of these. All right, so let's see. By graphing, I'm just going to show these with the algebra rules so you can check your work that way. I do recommend doing this by graphing. If that's what you did, that's great. But I just want to show the algebra rules here really quick. So this one is going to be 2 minus r over 3 is without the absolute value, this has 2 minus r thirds is equal to negative 7, or 2 minus r thirds is equal to 7. Let's see, I would subtract 2 from both sides. I'd multiply both sides by -3 to cancel out that divided by 3, and the negative will cancel out there. Wait, that's supposed to be a 3, excuse me. So that cancels out too, and you end up with r equals positive 27. Over here, do the same things. You end up with r equals -15. So that should be the solution set for that one. And over here, we're going to subtract 2 from both sides, because none of those rules work if you have like a 2 plus. If you wanted to use the algebra rules from the previous page, the 2 pluses messes it up. It just has to be the absolute value compared to something. Oh, but what we're saying is the absolute value is less than -14, but absolute value can never be negative. So it can't be less than -14. So this has no solution. All right, let's keep moving. Let's look at exercise 4. If you want to write an absolute value equation or inequality whose solution set is shown. Let's see. Okay, so to think of this as absolute value, you have to think of all these points that we're talking about here as points that are less than some distance away, and you got to find the middle of it. So right here, the middle between -3 and 3 is 0. So what we're saying here is the distance from x to 0 is less than or equal to 3, because you can go 3 out that way or 3 out the other way, or less than 3 units to get to some other stuff. So that's less than 3. Of course, you could just write that as the absolute value of x is less than 3. Or, excuse me, that should say equal to 3, because it includes the 3's with that solid dot. All right, this is saying the distance from the middle out to this point is, well, how far do you have to go from the middle to get to these? It looks like 2 units. Going from 5 to 7 is 2, or from 5 to 3 is 2. So you could write this as the distance from x to 5 is 2. All right, here, let's see, we're still talking about the distance from x to 5, but the distance from x to 5 could be 2, or it could be, 3 or 4, or anything bigger than 2. Same thing in the other direction. You could go 2 away or more than 2 away. So I'm going to write this as the distance between x and 5 is greater or equal to 2. All right, so that's that one. All right, is this the last one? Yeah, last one is exercise 5. We want to solve this inequality. So the thing about this is, it's got a negative on that side. So if it's got a negative there, the best way to do it is just thinking about it. Keep in mind that the absolute value of anything is always positive. So this is saying this thing that's always positive is greater or equal to -2, and any positive number is greater or equal to -2. So it doesn't matter what x is, whatever number you have on the left, it's going to work. So any real number is a solution. How about this one? Yeah, you could do this with a graph. That's great, by the way. I'm doing this the algebra way just because I know how to do it a little quicker. If you want to do these with a graph, that's fine. But I guess I should show the algebra steps just in case you like to do it that way. But I guess my favorite method is with a graph. So this ends up with the negative absolute value of 3 minus x over 2 is greater than -1. I'm going to multiply both sides by -2 here. It's going to give you the absolute value of 3 minus x. Oops, because it's a negative number, we got to change the direction, and that should be 2. All right, so let's see. This says the distance from 3 to x is less than 2. So actually at this point, you don't really need to use the complicated algebra rules because it's a simple absolute value of just a number minus x being compared to a positive number. So this is one where you want to think about it as distance. This says the distance from 3 to x is less than 2. So let's draw that on a number line. So if we're saying the distance from 3 to x, let's look at the distance from 3 to x. If we go 2 this way, that will put you at 1. If you go 2 the other way, that puts you at 5. So we're saying the distance from 3 to x is less than 2. That would include all this stuff here. So yeah, you can describe that as values of x that are in between 1 and 5. And that's that solution. This stuff is tricky if you're struggling with it. I'm sure you're not alone. We'll be talking about it this week in discussions or in office hours and get a head start on the homework. And I think understanding this stuff is really helpful for understanding Chapter 3. Is why we're sort of doing this first. The thing about Chapter 3 is it deals a lot with things being squared. It's about quadratic things like x squared plus 5 equals y. And something like x squared plus 5 has a lot in common with absolute value because x squared is always positive, just like the absolute value of x is always positive. So is x squared. So a lot of the reasoning that we're doing in this section is the same way of thinking we're going to be thinking in chapter 3. So let's get started on this homework, and I'll see you in the virtual classroom, I guess. Have a good day.